Hi, I'm Luci. I'm head of system engineering here at Telegraph, and I will take you today through cloud adoption and our DevOps journey. So let's start. As most of our companies out there, we started with software as a service in the cloud around 2008. And then slowly we went through the platform as a service stage, and then started to doing some EC2 and S3, which led us to the infrastructure of the service stage, and that quickly expanded. It went up very, very quick. We're using a lot of cloud services. Some of those there we don't use anymore, but there's a lot more that we're using and they didn't fit in there. So in the beginning there was a lot of lift and shift from tin to cloud. We were using the cloud as a classic data center. There was nothing automated. But going forward, there's some people recognize this. So going forward, we built Project Geop, get it out there. So it was born out of a need for increased agility and cost reductions. And it was our first cloud automation project. The purpose of this project was to move some of our big products to cloud. It was based on some Python scripts on top of Troposphere, the infrastructure defined in YAML, then transferred to CloudFormation, deployed to cloud, and then we were bootstrapping and doing configuration management with Chef. This was an ops project, and during that time there was still the handover from engineering to ops, all these projects. So this was the beginning. Geop, it was very good. It had auto-scaling, it had auto-healing, Route 53 integration, RDS, everything out of the box. You just define your stuff in YAML. It was some time ago. And it was using, at the time, Chef Solo. Then we switched to Chef Client. And as you may know, Chef Client has its own limitations. And then there was another problem. It made a lot of assumptions. And then assumptions made it fragile and very hard to change. That led to snowflakes. So what happens when you touch a snowflake? It melts. And worse, it's unique. So we end up with servers being changed manually, and then they turned into snowflakes, and nobody wanted to touch them anymore, which is a very bad thing to be in. So, as a response to this, we came up with a principle. The principle was 3 R's. Restart, reboot, relaunch. So what does that mean? So each server running on EC2 or each service running on EC2 needs to be restartable, rebootable, or relaunchable. That helped us getting aligned to the elastic principle of AWS, and also there's another principle that you should use all the storage options available. Don't stick your data on Slash, or make sure you can't relaunch the server and you end up in the same state. Preferably the server should be stateless, but if you need to have a state, then make sure you can reattach and get to the same state. Using this, we were able to build pretty complex projects, and it worked very well. The 3R principle was one of the first operational principles, and it was used by both engineering and ops to work together to do. But then because we switch away from CloudFormation or the YAML geotid, we were using scripting and AWS API, and this turned into a very complex and complicated setup very quickly. Again, we ended up with another abstraction layer on top of AWS, which we didn't want to maintain. So during around the same time, we had an experiment because the ops and dev relation started to work better. We moved one of our ops guys to the engineering team so he can work with them, unblock their sprints, and make sure the 3Rs is built and respected. And that actually worked very well. So we started to build a team, and we called them the system engineering team. And then, because of this problem, we let the team decide, so how can we solve this? And then the team said, go native. What does that mean? We're an AWS house, right? So what's the point of all these abstractions layers on top of it? Why not use AWS only? Or why not keep scripting to a minimum? And even configuration management, why should we do it if we don't have to do it? It was a team decision, and it worked. So we had to create a framework for this or an environment for this. And we came up with this idea. Probably most of you guys already do this, but we said each team will have a prod and a pre-prod account and so on. Inside each account, there will be a virtual private cloud. If they want to go multi-region, they can spin up another VPC in there. One important thing, we said we're going to have a separate CloudTrail central account. That's where all our CloudTrail logs go to, and nobody has that right access to. Then we have another separate account, which was hosting our Elk stack, the Craciun stack, monitoring, and we're going to deploy a vulnerability scanning solution in there. On top of this, we're working on using Google as an identity provider and implement single sign-on across all of accounts. There's a lot of them, so that should be very helpful. So let's drill into the account. So what did the teams decide to use? We had only one constraint, and then we gave the teams the opportunity to choose. We said everything needs to be CloudForm, so it's repeatable, it's templated. What services are being used is totally the team's decisions. So we have the templates. It's some teams store it in GitHub, some other teams in Bitbucket. We have a Bitbucket in our shared account. Then it gets picked up by Jenkins or Bamboo. Notifications goes to HipChat or Slack. It's all the teams who decide what they want to use. Then gets deployed to CloudFormation. So let's look what the teams decided to CloudForm. So different teams decided to use different technologies. Some of them started to use plain EC2. They were bootstrapping with some simple scripts or even Chef. And then some other teams started to use Beanstalk. It was very good for microservices and simple setups. But then when you needed more advanced customizations, then the EB extensions thing really didn't work. It was pretty opaque, and we didn't like it. So this happened organically. All the teams converged to Docker. They all started to love it, and also they started to use Lambda and more serverless API gateway. We have some pretty cool services running in Lambda. We have a Facebook bot. We have some Alexa skills there running all on Lambda. You should check them out on Echo. And by switching to Docker, we saw more than 50% reduction in costs. So if you guys are still having a hard time convincing a company to use Docker, I think this is a pretty good way to go. And the most important thing for us is that the teams decide what they want to use. We're not going to make any assumptions or make them use any tools. It's very important for us. So this is very easy to set now. It's CloudFormation, you deploy it. What about costs, right? This is maybe not everybody cares about cost, but I do. It's my job. So what happens with costs? As you may know, they can spiral up very quickly and can go out of control. It's not really a problem so much. Why? Because we have empowered the teams, and that helped a lot. So this is the costs of the pre-prod environments of one of our teams. And you can see the drop there. They decided to go to Docker. And then there is another big drop when they said, okay, we can use spot instances too. And it's always all the decisions. I don't have to watch these graphs every morning. And so it really works. Then going forward, one of the teams decided to build our data lake in Google Cloud. There's no restrictions. They can choose the technology they want. We already have like 70 terabytes of data in Google Cloud. We are also looking to extend that and use the cloud compute services, and mostly for any APIs that really need to sit close to the data lake. And also we are looking at Cloud Deployment Manager, which is the CloudFormation replacement in Google. It's still YAML, looks good so far, so we're looking to use that and extend our stay there. So at Telegraph, teams are fully accountable for what they write and what they deploy to prod. Everybody's on call at ops and devs. And here, DevOps does not only mean tool chains and cloud infrastructures. It also means independent cross-functional teams. And most important thing, it means bridging this gap between devs and ops through learning. And then we provide this opportunity for everybody who wants to learn. They can bridge the gap, and devs can learn more about infrastructure, logging, monitoring, security. And ops can pick up some dev tasks if they want. They can start with scripting, and if they really want to go to coding, they can do so. We provide an environment where you can learn if it's what you want to do. So this is our journey, and going forward, our focus will be on teams, containers, and serverless. Thank you.
So, any questions for Luci? Yeah, one over there.
Cool. I love the idea about kind of letting teams choose their own technologies, but how do you govern that? You don't want to be like supporting 7 different databases, supporting it, scaling it, hiring for people for those skills.
So there is the factor of economies of scale, right? But then if the teams, they actually build that product, they support it, they maintain it, then there's no problem with that, right? I mean, it's the knowledge is in the team. Of course, there is some. We're not going to start using everything, but there is some boundaries. But then inside those boundaries, the teams can choose anything.
So how do you define the boundaries? That you have like architectural forums?
Yes, we have a technical design authority, and then it has to go through that. We're not going to say no to everything and yes to everything, but
there is still kind of more process around it.
Yes, there is some process around it. Yes.
Cool. Any other questions? Please wait for the microphone before speaking, otherwise you won't be on the video.
you know when you had the graph, right, and then you were showing your cost reductions over the periods, etc.
Yeah.
You said the first one was for switching to Docker was the first sort of drop, and then what was the third one?
Spot instances. So we decided we can run pre-prod on spots. It works.
All right, cool. That was just.
Cool. Any other question? Anyone? No? All right.
You're done. Lucian, thank you.
Thank you very much.